Hello, and welcome back to another episode of Mr. Walker's Chemistry. We're continuing our periodic table unit here, and today we're going to discuss the properties that are shown on the periodic table. So these are not things that are expressly written on the periodic table, so to say, but they're things that chemists can memorize and understand and then use to help them when they do chemistry. For example, we're going to talk today about alkali metals. Alkali metals are very, very, very reactive. If I want to create some sort of dangerous situation, in other words, an explosion, I might want to look to the alkali earth metals in creation of my project or something, because they are so reactive. And these are things that we can use and figure out as we go through. Okay, so the objectives for today, for this video, by the end of this video you should be able to know the names of each group. So if you don't already, it might be a really good idea to get out your periodic table, print one out, sketch one up, do something. You just need the general outline of the periodic table, and on your periodic table write the names of the groups as I go through. I think that would be really helpful for your notes. I'm also going to discuss some of the properties of these groups. I'm mainly hitting on the big ones. I am going to give you some random facts. These are not things that I expect you to know. These are just, for fun, cool things to know. And also, you should know why these groups and their properties is important in chemistry. I've already given you one example on the title slide. If I didn't know that alkali metals were extremely reactive, and I start playing around with them and fooling around with them, I could cause serious harm to myself. So it's very important to know these things. Alright, so periodic properties. Just some questions for you guys, things to pique your interest. Did you know that you can predict reactions only by looking at the periodic table? You don't need anything else. This is why this tool, the periodic table, is so great for chemistry. Did you know that as you move down a group, the properties are the same? Remember, a group is a column. So as you move down a column, the properties of those elements are very, very similar. Okay, and just to give you a little quick refresher, go ahead and draw out the electron configuration for sodium and chlorine. Note, how many valence electrons does sodium have? Okay, how about chlorine? How many valence electrons does chlorine have? And if they want to be happy, i.e., I want to give them a full octet of 8 valence electrons, what's the easiest way to do that? So it might be something you can draw out. Draw out the Lewis dot structures for them, for sodium and chlorine, and then look and compare. They kind of look like puzzle pieces. You should be able to fit the 1 valence electron from sodium into the empty spot on chlorine. And this is how we can get sodium chloride. It's a very explosive reaction, in fact. Okay, so now we're going to get into the groups. So here's where you want to pull out your periodic table. And as I go through the groups, just write down on your periodic table what the name of that group is. Okay, so our first group is the alkali metals. All right, so this is going to be group 1, the very leftmost group on the periodic table. These are all metals. That's why they're called the alkali metals. And they should be lithium, sodium, potassium, rubidium, cesium, and francium. Okay, and these have the properties of low density. All right, so they're not very dense. They spread way out, so that if you are holding a 1 centimeter cube of, say, sodium, it's going to feel relatively light compared to something very dense like iron. Okay, has a low melting point, so a lot of these things are solids at room temperature, but with just a little bit of heat, even just the heat from your hand, you can cause these things to melt and become liquid. They are therefore generally soft, and the most important is that these things will react like crazy. Okay, they have a 1 valence electron that they are always trying to get rid of so that they can be happy. And so they will give it to almost anybody. They try and get rid of these things, which makes them very reactive. So some random stuff. You don't need to put this in your notes or anything, but things that they're used for. These things are found in Earth's crust. They are naturally occurring. They are used to make salts very commonly. So you've got things like potassium chloride and sodium chloride. Those are in your food a lot of times. Very important for your bodily functions. I mean, there's a reason that we have to eat salt, and that salt tastes so good. They're used in depression medication. You may have heard of lithium. Okay, lithium is a medication. There are lots of, in fact, there's lots of pop culture references to lithium out there, and they're usually songs about being depressed. So you've got this depression medication, lithium carbonate, and lithium has an effect on the brain that makes you feel better. Gunpowder uses potassium, and the second, as in the measurement of time, there are 60 seconds in a minute, that second is measured by the radiation of cesium-133. So there's an isotope of cesium, which is CS is the symbol, that is radioactive, and we measure that energy and the wavelength between the wavelength of that energy. So the distance between the peaks of that energy is actually 1 second. And that's used for atomic clocks, which are extremely accurate. You know, your watch and, you know, things like that are not going to be atomic clocks, but satellites use this because satellites have to be very, very accurate. If they're off by even a second, your GPS could be putting you in a whole nother state. So it's very important that those be accurate. All right, so on your periodic table, make sure you write alkali metals above group 1. Our second group is the alkali earth metals. Okay, this is column number 2 on the periodic table. These include beryllium, magnesium, calcium, strontium, barium, and radium. These are a little bit higher density, a little bit higher melting point than the first group, and they are therefore not as reactive. Okay, they're still reactive, but not as reactive. So on your periodic table above group 2, write alkali earth. Now, a little thing to help you remember this. Okay, alkali, 1 word, group 1. Alkali earth, 2 words, group 2. So that way you can remember the difference between alkali and alkali earth. And again, just random facts. I won't talk about all of these this time. Okay, radium is poisonous, used to treat cancer. Okay, so if you ever get radiation therapy, they're using radium a lot of times. You can use calcium for your bones, obviously. Milk of magnesia is magnesium hydroxide, and that is used to settle your stomach if you have an upset stomach. Beryllium is in emeralds. I think it's what makes emeralds green, is by adding beryllium to them. So all that sort of stuff is out there. So these are, again, these are actually all natural. Strontium is pretty neat. You guys are going to get to use strontium a little bit. It's used to make red in fireworks. So when we do our flame tests, if you haven't already done them, then that's the red color, is strontium. Okay, so now the transition metals. So these are from group 3 to 12. And the reason that they're called transition metals is because you are literally transitioning from the left side of the periodic table to the right side of the periodic table. Every single element in the D block for electrons is a transition metal. And the properties do vary. These are ones that are not really easy to say that they have a single property. Okay, we use these for all sorts of things. Stainless steel is iron coated in chromium. Surgery pins use titanium because titanium doesn't oxidize, so we can use that in your body, and it should last your entire life. Jewelry, of course, silver, gold, platinum, even titanium is used for jewelry. Brass is copper and zinc combined. Bronze is copper and tin combined. And then catalysts, like platinum, is a catalyst in your catalytic converter on your car. And that helps reduce pollution that comes out of your tailpipe. Light bulb filaments are tungsten. Interesting fact about tungsten is that it has the highest melting point of any element, any natural element. So they use the tungsten in the light bulbs because it's relatively cheap. So you can buy a light bulb, the old incandescent light bulbs, which still have the filaments. They're like $1 or something each, and they that metal in there won't ever melt. If you notice when they go out, it's just because they break. It's not because it melts. And then we use them in all sorts of other things, paint colors, etc. They add cobalt to paint, I think, to make it blue and those sorts of things. While we're talking about transition metals, there's this subgroup, which we're not going to use very much in high school chemistry, but you may see it later in college or in a career in chemistry, which I hope some of you consider. The inner transitions are the F block. These are the lanthanides, lanthanides and actinides, which are pulled out below the periodic table. These are called inner transition because really they're supposed to kind of fit into the periodic table in rows 6 and 7. So they just pull them out, and the only reason they pull them out is convenience. If we stick them into the periodic table basically doubles in width, and it becomes very difficult to use. So they just pull these out, and it makes it a little easier. Some properties of these, the lanthanides are soft and silvery, and the actinides are all radioactive. Every single one of them is radioactive. We use these things for all sorts of stuff. We use them in TVs. We use them to make alloys, which are just mixtures of metals to make them stronger, usually, or sometimes softer, depending on the purpose. And then the actinides, because they're radioactive, we use them for all sorts of things. We use uranium in nuclear power plants. We can use polonium in nuclear bombs. We can also use uranium in nuclear bombs. And we use americonium-244 in smoke detectors. So believe it or not, all of you have a little bit of radioactive material in your home. I hope you do, because I hope that you have smoke detectors in your home. And it's not dangerous to you or anything. It's just used because it's sensitive and it emits the radiation, and if it starts to get absorbed by smoke, then it knows that there is something wrong and it sets off the alarm. Alright, so just a quick recap so we know where we're at. We've got alkali as group 1, alkali earth is group 2. Transitions and inner transitions go from group 3 to 12, and you've got those inner transitions smished in there. I'll show you that. Let me pull up a periodic table here and show you guys what I mean by that, just because it makes it a little easier to see. Alright, so here we've got the periodic table. I know some of it's being cut off by the video here, but you can see here this blue is really, really helpful because it's showing that these two, the lanthanides and actinides, okay, named after the first elements of the row, really fit in right here. And again, if we stuck these in, then it would make the periodic table about twice as wide, and it's not nearly as useful when it's that big and it doesn't fit on a piece of paper anymore. Alright. Okay, so then after the transition metals, starting with group 13, we have the boron group, named because it starts with boron at the top of the group. This is your first group of the P block of elements. They contain a metalloid. Okay, boron is a metalloid. We're going to talk about the difference between a metalloid, and non-metal in future video or in the class. They all form +3 ions. Okay, think about why that might be. Think about how many valence electrons that these things will have. These are found in Earth's crust. We use them in all sorts of things. Pyrex, the glassware that you can bake with, is boron plus silica with some sodium and calcium compounds, and that makes it heat tolerant. So if you take just regular old silica glass and you heat it up to 400 degrees, it's going to break. But if you use Pyrex and heat it up in the oven, it won't. We also use it to control nuclear reactions in the control rods of a nuclear power plant, and of course, aluminum foil. Following the boron group is the carbon group. Okay, the second group of the P block starts with carbon, pretty simple. Lots of uses. Okay, diamonds, graphite, fossil fuels. Okay, gasoline is a hydrocarbon. It's hydrogen and carbon mixed together to form a molecule called octane. Okay, so when you go to the gas pump and it says 87 octane, 89, 93, it's the concentration of octane within the gas. Quartz, silica, so if you have a quartz-faced watch, it's using silica. Electronics, we use germanium that has other metalloids in it, and this produces semiconductors. Okay, then we have the nitrogen group. Third group of the P block starts with nitrogen, easy to remember. these all form, or many of them form, -3 ions. Again, think about why is that? How many valence electrons do you think nitrogen has? And is it more willing to give up electrons or take electrons to become quote-unquote happy, to have a full octet? Lots of stuff again. Okay, nitrogen makes up 78% of the Earth's atmosphere. Nitrogen is in your DNA. Nitrogen is very important for you. We use nitrogen in airbags. In fact, most explosives will use nitrogen because nitrogen has the unique property, it's not unique, but has the common, it's common among nitrogen to form 3 bonds, called a triple bond, and triple bonds are very unstable. So when you drop it, for instance, it will explode. Okay, the oxygen group starts with oxygen, very simple. Again, forms -2 ions. Think about why, all right? Don't be idle about this. Think about why might we form -2 ions? How is that important? And you guys know about oxygen, okay? It's in the air, it's in water, you can use all sorts of stuff. Fool's gold, which is called pyrite, is iron and sulfur combined. It looks just like gold, but it has completely different properties. Shampoo, Selsun Blue. Okay, it's called selenium. That's why it's called Selsun Blue. It uses selenium. All sorts of other stuff. All right. Halogens. This is a name that you should know. Okay, so halogens. Make sure you put that in your memory bank somewhere. The 5th group of the P block. And these are the fluorine, chlorine, bromine, iodine, and astatine. Astatine is the only metalloid. All the rest are non-metals, so iodine, bromine, chlorine, and fluorine are non-metals. They form -1 ions and are very, very reactive. Okay, so if you ever chance upon finding pure chlorine, okay, it is very reactive. Now, usually you won't find pure because it is so reactive. It's already reacted and formed something else. Okay, all sorts of stuff, foods, salts, sodium chloride, potassium chloride, I've mentioned those. Iodine is in your salt. We have iodized salt, so you get potassium iodide added to your salt. Iodine is very important for your health. If you don't get enough iodine, you get what's called goiter. If you don't know what goiter is, you can look that up. I won't describe it because it's quite disgusting. Bleach, okay, which is sodium, oxygen, and chlorine combined, and very useful for cleaning things. Chlorine in general is useful for cleaning things, like Clorox. Okay, Clorox, that word comes from chlorine, because they use lots of chlorine in Clorox. And the last group we have is the noble gas. Okay, noble gases. This is the last group on the periodic table, the furthest to the right. These are all non-metals. They are made up of helium, neon, argon, krypton, xenon, and radon. And they have full valence electrons and are therefore not reactive. Okay, these are the noble gases. I like to call them noble. They're actually named after a man, I believe. But I like to say that they're noble because they don't react with anything. So you think of them like nobility. You know, the king is not going to mingle with the peasants, so therefore he stands alone. And that's what I like to think of when I think of noble gases. Just a little thing to help you remember them. And these are used, again, for lots of things. I mean, I hope you're starting to see that no matter what element you're talking about, it's used for all sorts of stuff. Okay, chemistry is what gives you your modern electronics, your modern medicine, all that sort of stuff. I mean, it's just, chemistry is what gives us our stuff and makes life better. All right, so some things that we use stuff for. Helium. Helium is used to fill blimps. It's used for your party balloons, okay? Helium is going to get really expensive. Helium is actually a very strategic resource. It's going to get a lot more expensive in the future because currently the United States government controls a little less than half of the helium available on the planet, and the government has been selling off the reserves at extremely discounted prices because they got tired of paying the expense to keep helium, which is expensive to keep contained. So right now you can buy a party balloon for $2 or $3. You're going to be looking at $100 balloons here in about 50 years when we run out of helium. And it's used a lot in scientific endeavors as well. It's a very important gas because it doesn't react with anything. It's a very small atom. It can be used for a lot of things in science. Okay, neon signs, of course, we all know about those out in Vegas, and sometimes, the open signs in stores and things of that sort. And the emissions from Krypton-86, which is radioactive, is used to define a meter. So a meter used to be, the distance from the king's thumb to his nose or something silly like that. Well, every time you changed king, the distance of a meter changed. Well, now today with the advancements that we have in science, we can just say, hey, it's it's the wavelength of Krypton-86, and there you go. Okay, and then radon is, of course, radioactive. All right, so here we have our periodic table. I hope that what you've been doing as we go along is writing in above these groups what they are. All right, so just a very quick review. Alkali metals, one word, group 1. Alkali earth, okay, 2 words, group 2. Transition metals, transitioning from left to right. Boron group, carbon group, nitrogen group, oxygen group. Not as important that you know those. We're going to get more into that later. And then halogens and noble gases. So what you should know alkali earth, transition, halogen, and noble. Those are the ones definitely to know. If you can remember the names for some of these others, great. All right, but I'm probably not going to test you on those quite as much. All right, so be sure to go through these, start incorporating some knowledge, okay? Remember where the S block is, the P block, and the D block. Think about how many valence electrons these things have, and why does that give it their property? Okay, if I have 1 valence electron, like lithium, is it easier to try and acquire 7 electrons to become happy, or just give 1 electron away and become happy? All right. Usually nature finds the easiest way to do something. So think about which would be easier. All right. So I hope you learned something. Be sure to go back and review your periodic properties, and I'll see you next time.